Right, okay, thanks. As we're missing Bonfire Night, I thought I'd have a few fireworks on the screen as we're missing it. Right, okay. So, .NET configuration, it's easy, right? So you might think. So am I. I won't give you a full resume. I'm Steve Collins. I've been working with .NET, well, since pretty much it came out. Been around for 25 years. Last time I was in Sheffield was about 18, 19 years ago, doing some work for Westfield Health in classic ASP, VB6, ActiveX, COM, the dark days. So I blog at stevetalkscode.co.uk. Actually, I'll look at it on this side, it's easier. Tweet at stevetalkscode as well. So I've written a few blog posts about configuration because when .NET Core 2 came out, I started getting into it. I was having a few problems. I thought I'll just blog about it as I learn stuff. On that basis, I'm not an expert on ASP.NET Core and configuration. Someone like Andrew Locke is the expert, and I defer to them. But I do want to introduce some of the complexities that we have around doing configuration, show some best practices, things you can do to make your code a bit more readable and more testable, and ultimately try and get some solid principles in there. So I'm making the assumption that people are reasonably familiar with solid principles, but you don't have to be. Some of the stuff's fairly self-explanatory. What is configuration? So this was a slide I inserted not long ago. Michael Feathers, who's written a book about sort of refactoring old code. Config files, just global mutable variables put in a convenient place. And then he goes on the long rant about you shouldn't use configuration whatsoever. You should use continuous integration, continuous deployment, and have it all in your source code. Yes and no. I take issue with some bits, as you'll see in a bit. So why do we use configuration? So if I did a poll across the room, we get various answers, but I'd sort of boil them down into about 4 different categories. Values we don't want to hard code because they may just change. Ones that differ between our dev environment, QA environment, pre-prod, staging, prod. Sensitive values that should not be in source code. Now, even GitHub now warn you, are you sure you want to check this in? Because I think it's got a password in it. And values to disable, enable functionality, which I think Kev is doing a talk on as a lightning talk. He's disappeared. Right, okay. So I'll try and keep this brief. The history of .NET configuration. So let's go back to 2002. .NET comes out. And Microsoft go, oh, internet, HTML, XML, let's make everything XML. So XML web configs, the devil. Using XML schemas, which just goes on forever. I think that's part of the schema over there. In .NET 1.0, you're pretty much limited to your app settings, and you had limited to key value pairs, unless you were a real masochist and then you went into defining your own section handlers and section configurations and horrible stuff. Access through the static configuration class and its app settings. So we've broken virtually all the rules of solid with that straight away. Transformation files to do all your different environments. Yeah, that's okay, but it was still a bit of a pain. So in 1.0, we had something like that. Add a key and a value, which is fine. But then you had to do some nasty stuff in here. So we got our static. If I can find it. Oh, come here. Oh, no, it's not syncing. Configuration manager is a static class with a static property of app settings and a magic string of our key. And then if you wanted, because it's all strings, if you wanted an int or something, you had to pass it and do that. So it was error prone. What if you got a string instead of an int, then you get an error thrown and you had to have all sorts of exception handling all around it. So moving forward, .NET 2 came out. We got a nice GUI designer to make things a bit more bearable. But underneath it was still the horrible XML web config. So now you could set it all up. You could say what type it is, so it'd go and write some code for you to do your casting. You had some default values, and you had some code that it generated. Problem was, whilst it generated some code for you, if you wanted to do anything fancy, like have your own type, you had to write your own serializers and attribute them, and it was all a bit horrible. As a section group handler, and the web config starts to look even more complicated than it was in 1.0. So you've got this handler. I'll do it on here, it might be easier. So you've got this handler with a section group and a section that then has this wrapped up stuff with settings and values. So Visual Studio then tried to keep consistency between the auto-generated code, the designer, and what was in your web config. So you'd end up with something like going to change your web config, do a build. Oh, do you want to go and change your designer code? Well, no, I don't. I've just done a build. I'm not interested, especially if you had a transform going on in there. The properties weren't static. It created a regular class, but it had a singleton, which was a static, and everyone just went settings.default. Whatever. Oops, wrong one. So all in all, I won't read all this out, but basically it was pretty horrible, wasn't solid, made it really hard to test because you were bound to this configuration manager class. So, okay, how do you test that? You put a web config in your unit test, but you can't have more than one web config, so you ended up having to write sort of a project per different set of web config settings. Problems, configuration drift if you had multiple servers, unless you've got something like Octopus deployed to go and send the same code out. If you were manually deploying, there was a risk of configuration drift. One of the gotchas was if you went and re-changed your web config, it restarted your web service, which wasn't great if someone's in the middle of a transaction. Become really large and horrible. I've seen 2,000 line web config files where someone's got WCF in there and suddenly you've got about 200 lines of WCF configuration in there. If you've got one typo in there in terms of angle brackets, it falls over on its backside. It just won't work. Lastly, and I've touched on it before, leaking of secrets into source control. Because the web config was part of your project, that tended to get checked in, and the number of times you've got configuration strings with database usernames and database passwords in there, not great. So that's the history of .NET config. Now the future. .NET Core. Web config is dead, thank goodness, and so is the configuration manager. If you've got a core project, you don't get the settings designer in there anymore. If you're particularly masochistic, you can bring in the NuGet package because it's a .NET standard package, but it's not web config because in .NET Core world, a web application starts with a program CS, it's an app.config, but you just don't want to go there. So that's gone. .NET Core, everything is accessed through the IConfiguration interface. No more static configuration manager anymore. The implementation of that is created through the configuration builder using various different configuration sources. You're not tied to just an XML file anymore, and I'll come to that in a minute. You're not tied to files. You can use various ones like command line, environmental variables, and various other formats, and I'll do that in a minute. You don't need an application restart anymore, unless you want to, but what you can do, if you program it right, you can have a new change, and each new request will pick up that new change. You don't need to restart anymore. And lastly, the thing that I'll come on to towards the end is being able to create class instances based on your configuration without having to hand crank a lot of copy this string, convert it to an int, bind it to this property. So the different configuration sources. When you start up a new ASP.NET Core web app, you get this ASP.NET Core app version 2.1, 2.2.0. In 1.0 and I think it was 2.0, it was ASP.NET Core All. but they've deprecated that and it's all in this app. The main things you're interested in are these different configuration options. So by default, when you start up a new project, you get an app settings JSON file. But you could have an XML file, but it's not a WEB.CONFIG file. It's a straight XML serialization of a class. Or, for us old-timers who were around with sort of VB3 through VB6, INI files. Why they're there, I don't know, but they're back. But then things get a bit more interesting. Instead of files, you can bind stuff directly to command line arguments and environmental variables. So this comes a bit back to Michael Feather's thing about config files are a bit of a pain. You can bind to those things, so they're outside source control. And lastly, we're into sort of the zone of secrets. Now, I'll come on to user secrets, the Azure Key Vault, in a moment. Keep a file is a bit of an odd one, but the little logo in there gives it away. Early on, it was actually called Add Docker Secrets. But Microsoft wanted to be agnostic and not tie themselves to Docker, because there are other containers around, so it got renamed as Keep a File. Azure, you don't get in this app. You have to actually bring it in yourself. Now, the other thing with Azure is this was kind of the old way of doing Azure secrets. Now there's a dashboard where you can put in your values and it'll actually mimic your app settings JSON, but as environmental variables. But Key Vault gives us a good idea of what's going on as different secret sources. So in terms of security, I've gone from the files, because files are innately insecure, right the way up to Azure Key Vault, where if you're willing to pay the money, you've got hardware encryption going on. So yeah, text-based files, innately secure, insecure rather, because anyone can see them, because they're plain text. By default, your app settings gets committed into source control and deployed to the same directory. So if someone got into your main application directory, they're there. So if you've got secrets in there, well, they're exposed. So how do we keep the secrets outside of source control? The de facto way Microsoft now says, while you're in development, they've got this thing called user secrets, where you can effectively have your secrets outside of source control on your developer box, and they don't get checked in. What happens is you manage user secrets, and it creates a GUID inside your CSproj file. That then creates a folder, depending on your platform, that in theory only you can see unless you've given admin rights to everyone on your machine, and then they can go into your directories regardless. But in a dev environment, that kind of doesn't matter so much. And also, hopefully, you've only got your dev secrets in there, not your production secrets. So as I say, text files are sort of in the clear. So anyone with the file access can see them, can edit the JSON file manually in Visual Studio, going via the managed secrets. Or if you want to be a bit more flash, you can use the .NET command line, user secrets, you can list them, you can edit them through that. I've got a URL there, it'll come up a bit later. I will get these slides up. I tried to go into my OneDrive and it told me that too many people had downloaded the previous version of the slides and it suspended my access to it. So I'm going to get them up into something like GitHub or something. Key vaults. So these are the recommended way of holding your secrets. You're outside of source control, you're out off-site, in the cloud, hopefully with at least software encryption, but usually if you pay the dollar, hardware encryption. So the two biggies, Azure Key Vault, AWS. HashiCorp also have an offering, but for .NET, there's only sort of hand-cranked NuGet packages for it. HashiCorp haven't done one themselves, whereas Azure and AWS, they've got official packages. So, ignoring HashiCorp, Azure Key Vault. So you can choose software or hardware keys. It's fab if you're inside Azure, But if you're not in Azure, then you need to take into account the latency between your on-site going up to Azure, getting it decrypted, and getting it back down the line. There's a whole load of steps you have to go through. I won't rattle through it, but the key thing is you either need a certificate or a client ID and client secret. Then you're in the world of, well, if I've got to hold a client ID and a client secret, where do I hold those? Because I can't put them in the secret key vault. So you can't, not back to square one, but it's turtles on turtles. At what point do you end up with something that's unencrypted? AWS, I won't go through it. It's nearly one-to-one with Azure Key Vault. So, configuration sources and providers. We went through all the different types of configuration we can have, from the file-based ones, command line, over to the key vaults. All of them have an implementation of IConfiguration source. That's the thing that reads that format. So you've got a JSON reader, an INI reader, XML reader, etc. What you then do is you have an IConfiguration provider, and that takes those different formats and they converts them into simple string key value pairs. IConfiguration source has a build method on it, which takes the configuration builder. And then the keys in the configuration provider are a hierarchical path to get to your value, and I'll show that in a minute. Usually, all the built-in ones have an extension method on configuration builder. So you can just have your configuration builder, add JSON file, add an INI file, add XML file. So the reason I've got the coffee grinder on there is effectively, doesn't matter what type of input you've got, they're all different coffee beans. You put them through the grinder and they all come out the same as IConfiguration provider key value pairs. So let's take JSON files. So we've got a hierarchy there. Working day settings, default, a working day. So that's our configuration source. Turning it into configuration provider, we end up with the key value pairs. So our key is just colon delimited path to get down to the values. So had we had an INI file or whatever, they all end up in this format the same. Where previously we just had a WEB.CONFIG file, and if you wanted to make any changes to it for your different environments or what have you, you had a transform file that just changed that WEB.CONFIG file en route to your deployment. Now, we've got a layered approach. So you start with one file, and it overlays it with another, and another, and gradually you can build up your configuration. You can append different values, so you might have a value, so coming back to feature switches, you might have some feature switches that don't apply in dev, but they do apply in production. And you just add them in, and they become part of your settings. So, as an example, using our previous one, we've got our working day, which is 9 to 12:30, 1:30 to 5 o'clock. By default, when you start a new project, you automatically get an app settings development.json. Now, what will happen is that middle bit will be tied to development, staging, production, but you can create your own environments as well. And all that happens is it's a string interpolation of the environment that gives you that. So we're going to say during development, we're going to override the start time was 10 o'clock and lunch was 12:45. Now coming back to our user secrets, say we want to go and change that value just to debug something. Well, we don't have to fiddle around with our source controlled files. We can override it with something that's just on our file system and won't get checked into source control. So we'll override the start time with 9:30. So then we go into our IConfiguration provider. So we do our build of our configuration, and we end up with our key value pairs. So we've got our baseline one, our development one, and our users version. So what will happen is when you say build, it'll merge them down. Oh, sorry. Let's try that again. So it's a last in wins. So that will override the underlying values. You're not stuck to the ones that come out the box. You can go and write your own, and it's not that difficult. I've seen various YouTube ones about binding it to using entity framework to a database. You could do it to virtually anything, as long as you're able to go to your sources, retrieve them, and convert them into these key value pairs of hierarchies. Certainly SQL is a common one. gRPC is going to be an interesting one. Certainly I've seen someone do a demo of that, and I've seen someone do a demo of GraphQL. So how do we actually get these in? So I touched on the extension methods before. So when 1.0 came out of .NET Core, we didn't have a startup file, but 2.0 came out, and the default template gave you something like this. You've got a var builder of a configuration builder, set the base path to where it can find the JSON files, add JSON file. Optional, do I need it? Reload on change. Now that's the important thing I said about not having to restart your website just to make a config change. If that's false, it won't look at it, but reload on change will fire an event that can be picked up so that you can pick up the new values. Then we've got our environment name, add environmental variables, and then we go and build it. And then it gets set to this configuration property. That was 2.0. Well, Microsoft said, that's a bit rubbish, really. The reason being that if you set it all in your startup, you've got no way of intercepting it and going and adding some more in so you can do some testing, for example. So now, if you fire it up since 2.1, I think, you now get an IConfiguration config injected into it. So if we're not building it in startup, where are we getting it from? We don't repeat what's already there. In your standard template, you've got web host create default builder. And under the cover, it's setting these sources for you every single time it starts up. So we've got our app settings, our environment, user secrets, environmental variables, command lines. You can then go beyond that in your program CS and add some more. The only thing I'd say to watch out for that is if you want your user secrets to override stuff, you'll need to put user secrets in again because of the whole layering. That's third in line at the moment. If you want that to override, you're going to have to put it in again so it overrides whatever you put in before it. So this is the standard template you get when you fire up a new ASP.NET Core application. Create web host builder, args build run. Comes in with the args, create default web builder, args, use startup. So the args are your command line arguments that will get bound on the command line source. But that's fairly limited. You can't really test it because, yes, you can sort of test this bit, but then you've got to build it, and you definitely don't want to run it because that's going to fire up your website. So how do you make it testable? So you just do a bit of refactoring. First off, if you want to add some special configuration sources just for outside of your project, you can add a JSON file. You can put your path into some other file that's just outside the application. Optional true, change and reload. And these are the different extension methods you can use to add some more stuff in. So, okay, we've got our new method. How do we wire it in? We'll just put it after the use startup, and then this will override what's gone before it. But we've still got the build and run. So let's take the build out to its own method and just say build the web host using create web host builder, run. Then what we can do is we can mark our main with exclude from code coverage, for example. But now we can go into this build web host from our X unit, for example. We can then still override that with whatever sources we want to do in our unit test. So for example, in this one, I'm going to create a dummy for the command line args. And I've got this key value pair that I want to just test my unit test. Default builder, program create web host builder args. That's going to pass those command line args in. Then there's an extension method, configure app configuration. So this is just before you build. You can start adding. So there's an add in memory collection. Now you wouldn't really use that in standard production code, but it's really useful for unit testing. So I can then put my dummy values in for unit tests to see if those are going to come out. Then I can call my own build web host, which is doing the build underneath. That's going to give me my web host, that's right. Then I can call services, get service on my configuration, and then I can do an assert to say, have I got the values I want? So that way you can start testing what would happen if I change my configuration values around. Because you may have some logic based on your config values. And hopefully, you'll get a green light on your test. So I've said that IConfiguration replaces Configuration Manager. There's a temptation to treat it like Configuration Manager because much of the methods and properties are very, very similar. The main one being is to pass a string key into it. Please don't do that. Please don't. But the usual IT caveat, it depends, unless it makes sense to. The reason I say that is, going back to my previous slide, is if I've just got something very constrained to, say, a unit test, or I'm just doing stuff within the program CS or my startup, then that's not going to leak out to the rest of my code, and it's not a big deal just to reference your key directly. When you get outside of your DI container, that's when you don't want to be using these strings left, right, center. Because all the usual things of if you've got typos in there, if you want to change something, you've got to go and search and replace. It's a pain in the neck to deal with. Pretty much says what I've just said. But yeah, sometimes it is okay if it's during the DI registrations, or if you're encapsulating inside a class. So it's just the one place you've got all these strings. So it's only one place you've got to go hunting for them. But wouldn't it be nice if we could say, take my configuration and bind it to one or more classes? So we can. Configuration bind does that. As long as your JSON marries up to your class structure, well, I'd say JSON, the hierarchical structure within the configuration provider marries up to your class, it's just a JSON deserialization. So it can go and bind it. But there's a few gotchas with the bind. The main one is you've got to instantiate a class and pass it in, and then it will do the binding for you. But also, once you've bound it, it's not listening for the changes that are happening in your configuration source. So there's a better way of doing it. Configure T. What this does is it does all the wiring for you. It sort of says, just bind it to this type using part of the configuration. It also automatically registers your configuration source to listen for changes. So in this one, I've got a class myAppSettings, and I can say, go and get the section myAppSettings, which marries to the class structure. It will go and bind it. But this is why I started writing my blog in the first place, because I read about it, went, okay, configure, and then I should have read the documentation, because there's more to the options pattern than meets the eye. What it does is, under the bonnet, it registers 3 different generic interfaces for you. IOptions-T is a singleton, which is a value. Singletons will get bound when your application starts up and never change. Regardless of whether you've said your configuration source can notify changes, that stays the same because it's a singleton. It's created and it stays there for the lifetime. Options monitor is another singleton, but this time it's got a current value that does listen for the changes. So you can ask for the current value and it will say, okay, whenever it's been changed, I'll give you what it's changed. And then you've got a halfway house, iOption snapshot. So this is a scoped lifetime. So what happens is in ASP.NET world is you get a new scope every time you receive an HTTP request in. And it lives for the lifetime of that request, you do what you want, and then it disappears when your response goes back out. What will happen is it's effectively like iOptions monitor, but it will call it at the start of that request, when that scope starts, and then disappears. So the next request comes in. If it's changed again since the last request, that new request will get the new version. So this is all based on the reload token. Now, the file-based ones have file watchers on the files you've registered. So those file watchers get notified, and what happens is the configuration provider keeps a cache of the values. It receives that, and it sort of says, oh, has it differed? Yes, it's been updated, and I'll go and update my cache on there. Other things like databases, or if you use REST or something like that, well, there's no natural way to get notified of the changes, unless you're using something like SignalR or something that pushes the notifications to you. Databases, there used to be a way of getting SQL Server to notify you, but it maintained connections and it was all a bit clunky. So, I've done my configure T. I've got a class working day. So I've got my working day in my constructor. I'm expecting to get my bound class instance. And I got a null, and I didn't quite understand why. And this is when it went, should have read the documentation. What you actually need to do is ask for one of those interfaces. iOptions, iOptions snapshot, or iOptions monitor. So once you've got those, you actually call the appropriate property and you get your value out. And everything's great. You've got your bound value. You can do whatever you want with it, pass it down through all your different functions and what have you. So the lesson I learned is read the documentation. But I'm a developer. I don't read documentation. But in this case, I wish I had. The next bit is you've got to have these unwrapping properties on there. But the options thing is a NuGet package. Now, if you've got your value, do you really want to have to bring that NuGet package into various libraries? So say you've got a library for your domain objects, a library for business logic, whatever. And say you need some of this configuration stuff. You don't really want to drag along the NuGet package into every single one of those. You could say, okay, I take my configuration object, and every time I need to pass it down the line, I've got to unwrap it. So at some point you unwrap it and then just pass that down. But that means you've then got to have signatures that sort of deal with that. So it's all a lot of plumbing code that you've got to put into your own code. The last bit is if you've got one of those iOptions as a parameter to one of your methods, you've got to mock iOptions, mock the right one, which is yet more plumbing code that you've then got to put into unit tests. There's another way you can do it. Within your DI container registration, you can do the unwrapping using a Lambda. So what we can say is, configure my working day, getting that. That's going to give me my iOptions snapshot of working day, for example, or iOptions or iOptions monitor. But then I can use a Lambda that says, actually register working day. And when I ask for working day, it'll come in here, and then it'll go and grab my iOptions, it'll give me the value. So the code outside the DI container doesn't need to know about iOptions. You've just got your configuration object. Just make it a bit clearer. Things get a bit more tricky if you want to do something with your configuration object. The options pattern assumes that your configuration object is just a DTO. It's just a bag of properties that you're just going to pass around. But coming back to what we were saying about casting, say, for example, in my example, I had my time expressed as hours and minutes, but that's a string. If I change that to a time span, that won't deserialize because it's the wrong format to deserialize to a time span. So we've got to step in the middle and do something. So my DTO then has to have some logic, but the trouble is the serialization takes place outside my DTO. So I then have to have a string version of my times, then a time span version that my code actually uses. All a bit messy. The second bit is, say I want to do something clever and inject something into my object. IOptions pattern doesn't let you inject anything. It expects a constructorless, a parameterless constructor because it's going to instantiate it. So there's a generic constraint on there. So how do you get around it? So first off, I want to turn my strings into time spans. I want to read the configuration and say, for example, I want to do some interface segregation on there. And lastly, I want it to be immutable. How do I do that? Going back to, is everyone familiar with the Gang of Four design patterns? Yeah? The bridge pattern can do this for us. Now, there's a bit of confusion between bridge and adapter. I went back to the Gang of Four, but because someone challenged me on this, said that's not a bridge, that's an adapter. So I went back to the book. Adapter make things work after they're designed. You've got some pre-existing interfaces or classes, and you can't change them. Whereas a bridge, you're thinking ahead. You're doing that conversion while you're writing it. What that does is the definition of a bridge is it decouples the abstraction from the implementation. In this case, what we want to do is achieve it so that all code outside the DI doesn't need to know about the implementation. So, time for a bit of refactoring. I'm too fat-fingered to do this live, so I've just got it as animations. So we've got our working day class. Start time, lunch end, end time. So firstly, they're all strings. They've all got getters and setters because one of the rules for IOptions to work is you've got to have setters on there for it to be able to deserialize into it. We'll take a copy of it and rename our old one as reader. And we'll bank that. The next thing we'll do is get rid of the setters on this bridge class because there's no point in having setters on there because you can't write back to your configuration sources, especially as they're aggregated from multiple sources. Where would you write back to? Whilst you don't want them to be mutable because what's the point of having that mutability? Because you wanted the configuration settings that came from your sources. So you make them immutable. Now we can change it to time span, which is what we really want. And then we can extract out an interface on that. And we'll bank that interface. Now a bit more refactoring. Now I said that our original reader class couldn't take a constructor, but our bridge class can. So what we're going to do is we're going to take the IOptions monitor in this case of the working day reader and extract out the value. So that gives us something to, we've got our reader object to work with. Now we can have a helper function to go and cast it into a time span by using the appropriate format, and we can then use that to bind to our new properties. So now we've got our bridge. Now we need to go and register it. So here's our startup class, configure services, as we normally have. We're going to do configure working day reader from the section that we did as before. But now we'll add a transient of iWorking day, working day. Working day is our bridge, which the constructor says, I'll take one of those IOptions monitors in. So then you can just pass your iWorking day around. It's read-only, so it's immutable. it's got the timespans that we want, and it's got the injected value that we want. So we can start passing that around. Everything outside of DI doesn't need to know about IOptions pattern. Just make it a bit larger so everyone can see. So I've rattled through that at quite a pace. So what we'll do, so we started with our IConfiguration source, which was our JSON files, our INI files, our command line, etc. They got all converted into configuration providers. The configuration builder then goes and aggregates them, so we end up with an IConfiguration. The IConfiguration is registered inside the default web host builder, and then our DI container has got our IConfiguration, the IOption snapshot versions, sorry, IOption snapshot, IOptions monitor, IOptions of our reader class, and our iWorking day. Now you can still get to these because they're just in DI. You can get to them if you want, but it's best not to. All you're really interested in is iWorking day. The implementation of iWorking day is working day, which took our IOptions monitor, which bound the reader to give us our properties. So all that refactoring has just gone through this path. Why does this help? Come back here. So as I've reiterated several times, we're not exposing IOptions. You don't have to bundle it around as a NuGet package in all your different libraries that want that configuration information. Makes it easier to mock because you're not having to mock the various IOptions interfaces. All you're mocking is an interface. All the mocking frameworks can do that, or you can just write your own hard-coded mock of it. You can then break them down into finely grained interfaces. So say, for example, you've got a configuration where you've got 3 different configuration strings, one for SQL, one for MongoDB, one for Oracle. The stuff that does SQL stuff doesn't care about the other 2 connection strings, and vice versa. So you could use interface segregation to say, I'm going to have an iSQL connection, an iOracle connection, an iMongo connection. If you define those in a common library, then everything could just rely on those interfaces. So that's your I in the solid. Future developers don't need to know about IOptions. I keep saying that, but that's the big selling point of all this. Gets around the problem of configure not being able to accept parameter-based constructor classes. By decoupling, you can allow for all the customizations that makes a unit testable. But then let's go back to the right-hand side of that chart I had earlier with the secure stuff. One of the big no-nos is not having secrets in source control. So we don't want them in app settings JSON. Sensitive values shouldn't be in source control, preferably in one of those key vaults. But what if you don't have access to a key vault? Now, one of my clients at the moment, it's all on-prem. They've got no interest in Azure or AWS. So how do you secure it? Okay, so like I touched on before, you can bring it out to command line arguments or environmental variables. If you're using Docker, you can put it into Docker secrets. But then if you're got a build of your Docker secrets, then you've got something exposed in that build, but that's probably outside source control. Your last option, which isn't great, but it's a way around it, is to have a JSON file, but it's not in source control, and when you deploy it, it's outside the application folder. Still insecure if plain text, though. If someone can get on the server, they can still see it. So wouldn't it be nice if we could put some encryption in there? Our first thing is, base64 encoding is not encryption. Number of people who think it is, but it isn't. Don't roll your own encryption algorithm because something's going to go wrong. It's not going to be wholly secure. Ideally, you might have a server certificate that you can use and use one of the certificate-based DNS encryption, decryption algorithms that are built into .NET to deal with the certificates. You could use the DP API, but when I looked into it, I found this. Oh, this doesn't want to work. Come on. I'll do it on here. Not intended for indefinite persistence. They actually last for about 90 days. So you could go and deploy it into production, then 90 days later, boom, it won't work anymore. So, what do? You need to look at a different encryption algorithm. So go as high as you can, but obviously there's a performance impact. The more encryption goes on, it's more load on the CPU. So you've got to weigh up encryption security versus performance. Things like AES have a key IV pair, and going back to the Azure Key Vault, you've got your client ID and client secret. At some point, you've got something that's going to be unencrypted to decrypt stuff. So the best thing to do is put those somewhere that's definitely not source controlled and not obvious, like environmental variables, command line args, etc. The problem is at some point you've got to have something exposed to be able to get to the encrypted stuff. And definitely not in source control. If you've got multiple things you want to encrypt, it's worth having different sorts and hashes and different keys and IVs for your different key, your different values. So that if one thing gets hacked, well, not all your different secrets can get exposed. Once you've called the appropriate method to go and do the encryption, it gives you a byte array, and at that point you can go back and use your base 64 to get it into a text thing that can go into an environmental variable, command line, JSON file, whatever. So how does this affect our bridge? So what we can do is we can have a common interface that does the decryption, have an implementation, register the interface and implementation with our DI container, and make it part of our bridge class's constructor parameters. Validation. Since .NET 2.2, you can do it much in the way you do it with Entity Framework. You can attribute it and say this is required, this is to meet this regex, and so on. The problem with that is it's not compatible with the configure T and I options model. You have to go and do this add options stuff manually. And of course, then you've lost your ability to listen for changes in your configuration. What I tend to do is I create my own validation interface and implementation. So something like Fluent validation, can use that. Or we could just have some hard-coded validation in there and just inject that into your bridge. So let's put it all together. So, the program file. So as I say, we'll make our main exclude from code coverage because we're never going to run that from our unit test and we don't want that showing up as not being covered. We've got our standard default builder, use startup, configure app configuration with our custom configuration. Now this, for example, is I've gone to the root of my C drive to go and get a JSON file. If you're going outside of your applications folder, you need to provide one of these physical file providers. So that way it can get outside of your application. We'll have our standard app settings, so there's no secrets in there. And then in this file that's outside, we've got a couple of secrets that have been encrypted. One's a SQL connection string, one's an Oracle connection string. For the encryption decryption, we'll just have some standard interfaces. So we'll have a crypto algorithm that just says decrypt by base 64 text and give me a string. We have a crypto algorithm, which is the thing. Now that could be your AES 256, AES 512, whatever algorithm you decide you want to use. By having a crypto factory, you've then completely decoupled it. So if you want to change your algorithm later on, because your previous algorithm's been hacked, say, all you've got to do is just put in a new implementation and register it with your container. The iSettings decrypt is just a thing that's going to take the appropriate key and a dictionary of values, and a settings validator is just going to say, just go and try and validate my settings and give me an aggregate exception of all the different problems I may have found with it. As I mentioned about having interface segregation, we've got our core app settings, a SQL connection string, and an Oracle connection string. We can then wrap that up in one interface that binds them all together. So here's our new version of our bridge that deals with it all. We take our iOptions monitor app settings, our decryption, and our validator. We get the unwrapped version. If, for one reason or another, we get a null, we throw a null exception. Decryptor is null, throw the exception. Validator null, throw the exception. We try and validate it. If the validation fails, we throw the validation exception. So now we're into our core bit. Application name comes from our app settings application name. Our SQL connection string and Oracle connection string, we go and decrypt them, passing in our properties. Now, unfortunately, in .NET Core world, once it's in memory, all bets are off because it's been decrypted. There was the secure string, but you can't read something out of secure string without a lot of fiddling around with the API. And basically, Microsoft don't even support secure string in .NET Core anymore. Then we've got our three properties that are just read-only. So we've got our immutable class. Sorry, I forgot I had all these highlighted. Right, okay, so, yeah, I'll just, right, okay, so this is our registration. So we've got our salt and password. We've got going to add our crypto factory, and I've used an AES managed. Then we've got our iSettings decryption, the settings decryptor implementation. That can be a singleton because there's no state to it. We're just calling a method on it that says decrypt. Then we've got those decryption and validator singleton. Then we add a scope to iSettings resolved, which is our bridge, which takes the previous ones in. And then what we can do, this is where we've got our interface segregation. What we do is we say, for those three interfaces, we'll go and get the service of the iSettings resolved, which is our bridge. If you just went and said, go and register my app settings bridge against all three, you get a different instance coming back. Whereas really, you just want the one instance coming back. So that's our startup. So finally, we get to our controller, where we say, I've got an iSettings resolved. If it's missing, throw an exception. But ultimately, we can either, that one's got the app settings resolved, but this one just takes iapp settings. It doesn't care about the connection strings. It just wants the application name. And then lastly, within our MVC page, we can then call on our model and expose it. Obviously, you don't want to expose your encrypted ones, but you can then pass it down to whatever. Similarly, if you've got classes that depend on the configuration and they're registered with the DI container, the DI container will go and populate those classes with your bridge configuration. So that's it. So we've looked at the .NET Core configuration system. We slagged off the old WEB.CONFIG stuff as well. Everything's about IConfiguration. We've shown the options pattern and how to retrieve values in real time. How to hide the options pattern using a bridge class, and how to refactor stuff so that we can apply some solid principles to it. And that's it. Some resources. The main ASP.NET website has got some big fundamentals about configuration. User secrets is in a different place for some reason, but Andrew Locke's blog. When I was first dabbling around with ASP.NET, I went to whatever I Googled, I seemed to end up on his blog site. Then Manning approached him and he wrote a book about it all, and there's a really good chapter about configuration in that book. Well worth reading. Steve Gordon has done a Pluralsight course on configuration. He's also got a really good Pluralsight course on dependency injection as well. The stuff about Azure Key Vault. I read this book recently and it hit two bases. There was all the stuff about cryptography, but it's also got about 3 chapters on Azure Key Vault as well. So if you are using Key Vault and you're not inside Azure where you can go and use the dashboard to set your configuration up, it's worth a read. A lot of what I've described is based on a 4-part blog post that I did about 18 months ago. So you can look at my website for that. There's a demo in that bit.ly on GitHub. I'll put these slides up, but as I say, for some reason my OneDrive has locked me out, so I've got to find another way of publishing these slides. And lastly, if you want to follow me, I'm at Steve Talks Code on Twitter. And that's me. Thank you.